we know is our read to stream async. So thread 1 hits return. It's freed up. It's able to interact with the user now. Meanwhile, this code's running out of background thread. And when it's finished, it says, hey, .NET, I'm all done. The calling thread jumps back in here, but we're now going to switch onto case 1 because again, remember, we set state to be the value of 1 before we left. So we jump back into case 1 where we assign our local variable the value of our field. We set the field back to default to help optimize our code a little bit. And we set our state to be -1 before we move on, just like last time. So we'll jump down to IL_00E7, where we call the next line of code, which is deserialize async, which we are awaiting in our code. But just like last time, what's going on under the hood is we're setting that value to a local variable here called awaiter. We'll check to see first if it's completed, because if it is, we can break, meaning we'll break out of our switch. Or if it's not, then we'll assign the state to be 2. We'll set our field U003 to be the value of the awaiter. Since awaiter is a local variable, and we want to store that in a field so we can retrieve it later. And then we await the completion of the variable awaiter, and thread 1 returns. Thread 1's now interacting with the user. It's freed up, while deserialize async is running on a background thread. Okay. So finally, we enter switch 2. We get to our last case where, just like last time, we grab that value of U_3, set it to our local variable. We default out that field to help out the garbage collector and help out our performance. And then because this is the last case, this is the last time we're using the await keyword, we set the state back to -1. And now we can break out of our switch. So we break out of our switch, and just like we expect, we grab the result from awaiter.getResult, which is our list of library models. If that result 2 is null, meaning our list of library models is null, we'll throw an invalid operation exception, just like we've told it to do over here. And if it's not, then we set the result 3 equal to the value of result 2. Continue on by finally setting the state to -2 now that this async task method has completed. This is the last line of code. And we finally can set the builder's result to be the value of result 3, our list of library models. And now this task is completed, and whoever called this task, whoever's awaiting this task, will get the result here that we now know is result 3, which is our list of library models. Now, this is pretty cool stuff because if you think about it, .NET was actually created before multi-threading existed. Back when back when .NET was first invented, we had single-core processors. Nowadays, we have multi-core processors, and each core can work on a different thread simultaneously, allowing us to do asynchronous and multi-threading operations. But when .NET was first created, none of that existed. So the creators of .NET didn't have to worry about multi-threading or asynchronous programming because there was only one thread. The smart engineers at Microsoft were able to design this state machine under the hood that is auto-generated for a compiler to generate all this code for us. And us, as developers, we get this nice syntax of async await, keeping our code very readable. While in reality, we're running on a runtime that was not initially created for multi-threading. And I think this is just incredible. I think this is a beautiful method that the engineers at Microsoft have come up with to make our lives easier. But it can also introduce some complications. Like I mentioned earlier, you're going to see weird things like move next in your stack traces, which isn't code you wrote, but it's code that the compiler generated for us. And the other big gotcha here inside of move next is this try catch block. Now, this try catch block expands all the way down to here. And essentially, it encapsulates all of our code, all of the code I wrote, like deserialize async, like get async on HTTP client. All of the code that I wrote in my method is now encapsulated inside of a try catch block. And this means that if any of my code throws an exception, like if ensure status code throws an exception because the response from get async was not an HTTP OK, well, that exception is going to be caught here inside of move next. Now, the good news is, as we can see here, we set the exception on tBuilder, meaning whoever calls get libraries, as long as they await this task, so as long as they say await get libraries will rethrow my exception. So just by awaiting the task, that exception gets rethrown. But there's some really, really bad code I've seen out there where folks don't await a method. They just say, I'm going to run get libraries on a background thread. I don't care when it finishes. I don't care about getting the results, which a little weird for this example, because why would you call get libraries if you didn't want a list of the libraries? But we could always just say task.run and not await it. That's very, very dangerous, because what really happens under the hood is if our code throws an exception, that code gets caught here. And because we did not await the task, that exception gets swallowed up. It essentially just gets disposed of by the garbage collector. And that exception's gone forever. And you might think, isn't that a good thing? Because I hate exceptions. Exceptions crash my app. I don't want exceptions to happen. But actually, exceptions are a good thing. Exceptions mean that something exceptional has happened in our code that .NET didn't know how to handle. And what we should be doing is catching that exception that gets thrown and handling it ourselves. So if I call await get libraries, which is the right thing to do, we always want to await our tasks so that we can have those exceptions rethrown automatically for us by .NET. What we should do is call await get libraries inside of a try catch block. And then inside of that try catch block, we can catch an invalid operation exception, or we can catch the exception that comes back from ensure status code if the get async response was invalid, and handle that ourselves, because .NET's not going to know how to handle that. So anytime you see code calling an async task method and it's not awaiting that task, that is very, very dangerous code. And in fact, it's code that I used to write myself back in the day before I learned and looked at the code under the hood here. And it's actually one reason why I'm so passionate about sharing this information, because I used to make these mistakes. I used to say task.run and run code on a background thread and not care about when it completed, so I didn't await it. But what really happened in my real world apps that I published to the app stores is that the code inside of task.run would throw an exception. I, in my code, would assume that everything worked perfectly, but it didn't. And that exception was thrown, and I never knew about it because my app kept running. And now, because my app is still running and an unhandled exception occurred and got swallowed up by move next, this try catch block inside of move next, well, that put my app in weird states. So for example, I would have my user hit that submit button. I would show a little spinning indicator letting the user know that something was going on in the background thread. And when that exception would happen and I didn't await the task, so meaning I never knew that exception was thrown, well, my code keeps executing as if nothing wrong happened. And so now I still have that activity indicator spinning. I still have my button disabled. I don't allow the user to enter in any more text. And now my app is in this weird state where it's no longer calling an API, but at the same time, the user's not able to interact with anything. And that led to me getting some weird feedback, some poor reviews in the App Store. So all that to say, anytime you call a task, always await it, because that task might have an exception thrown inside of it. And because of the way .NET generates code for us for every async task method, it's going to catch that exception. And as long as we await the task, that exception gets rethrown to us as the developer. We can catch it, we can handle it gracefully. If we don't await that task, that exception gets swallowed up forever, and our app risks entering an unknown state that we never actually prepared for. Now, I know I've thrown a lot of things at you, so let's do a quick review before closing out this section. So let's do a quick review before closing out this section on the compiler-generated code. First, the async keyword adds about 80 bytes, because as we saw, every time we add the async keyword to a method, the compiler generates a ton of code for us, and that code takes up space in the final app. So our DLL that's generated by the compiler will be about 80 bytes larger because we use the async keyword. Now, this is 80 bytes. This is not 80 kilobytes. It's not 80 megabytes. It's not 80 gigabytes, just 80 bytes. And to be honest, nowadays, 80 bytes doesn't really mean much. For me, in my app, I use async methods hundreds, if not thousands of times. I don't even concern myself with the fact that the async keyword adds 80 bytes. But if you are working on, say, an IoT device or an embedded device, something where memory is limited, this is good to know. So the async keywords adds 80 bytes because every async method becomes a struct, specifically in release configuration. As we saw when compiling in the debug configuration, it actually keeps it as a class and doesn't do the extra optimizations as a struct. But when we compile for release so that we push our app to production, every async method becomes a struct. We also need to await every task because non-awaited tasks hide exceptions. And again, exceptions are a good thing. Exceptions should be celebrated. Exceptions should be caught. Exceptions should be handled. I know as C# developers, exceptions can be annoying because stuff's going to happen that when we wrote our code, we didn't expect. And that's okay. As long as we catch those exceptions and handle them gracefully, everything's still great. And in fact, that's what we should be doing as C# developers. So make sure to await every task, because when we do not await a task and an exception's thrown inside of that task, it's caught inside of that try-catch block inside of move next. That exception is gone forever, and there's no way for us to handle it gracefully.